For a 50 amp 3-wire welding outlet, a full-size number 6 equipment grounding conductor, or EGC, is required. This requirement stands regardless of the conduit type, whether it is EMT or another type. The number 6 EGC must run directly from the panel neutral bar to the welding outlet ground screw. It is not permissible to use a number 10 American wire gauge, or AUG, grounding method for a 50 amp 3-wire welding outlet. The National Electrical Code, or NEC, does not permit the use of number 10 AWG as an EGC for circuits that exceed 20 amps. For 20 amp receptacle circuits installed in EMT, a number 10 AWG EGC is acceptable. The number 10 AWG EGC can be run from the panel neutral bar to the ground screw and the receptacle box. Number 12 AWG wires can then be used to connect the ground screw to the individual receptacles. If the decision is made to pigtail the number 6 EGC with number 10 wire, it is permissible. The pigtail connection should be made using a wire nut and must be properly sized to handle the ampacity of the circuit, which is 50 amps in this case. The essential takeaway is that for a 50 amp 3-wire welding outlet, a full-size number 6 EGC is mandatory. The number 10 AWG grounding method is not acceptable for this application. For 20 amp receptacle circuits in EMT, a number 10 AWG EGC is acceptable. Pigtailing is allowed, provided it is executed correctly, ensuring the secure and appropriately sized connection. The equipment grounding conductor, or EGC, plays a vital role in electrical safety. Its primary function is to provide a low impedance path for fault current to return to the source, which facilitates the quick operation of overcurrent protective devices like circuit breakers or fuses. This rapid response minimizes the duration of a fault, reducing the risk of electrical shock and fire. The NEC outlines specific requirements for EGC sizing, installation, and material, ensuring that the grounding system functions effectively. These requirements are based on the size of the overcurrent protective device protecting the circuit. The EGC must be sized appropriately to safely carry the maximum fault current that could occur. EMT, or electrical metallic tubing, can serve as an equipment grounding conductor under certain conditions. However, it is crucial that all EMT connections are properly made and tightened to ensure a continuous and reliable grounding path. When EMT is used as the EGC, fittings must be listed for grounding purposes. The use of supplemental EGC within the EMT may be required in specific situations, such as in healthcare facilities or where sensitive electronic equipment is used. The practice of pigtailing involves connecting multiple grounding conductors together using a connector, typically a wire nut. This allows the single grounding conductor to serve multiple devices or equipment. When pigtailing, it is essential to use connectors that are appropriately sized for the number and gauge of the conductors being joined. The connection must be mechanically and electrically sound to ensure a reliable grounding path. Antioxidant compounds may be used to prevent corrosion at the connection point, especially when dissimilar metals are involved. The NEC provides tables that specify the minimum size of EGC based on the rating of the overcurrent protective device. These tables take into account the ampacity of the circuit and the potential fault current. It is crucial to consult these tables to ensure that the EGC is properly sized. For example, NEC Table 250.122 provides guidance on sizing EGC for various circuit ratings. When dealing with welding circuits, it is important to consider the specific requirements outlined in the NEC for these types of installations. Welding circuits often require larger EGC due to the high currents involved. The NEC addresses welding circuit grounding in Article 630. This article provides specific guidance on the sizing and installation of EGC for welding equipment. The grounding electrode system provides a connection to the earth, which helps to stabilize voltage to earth and provide a path for ground fault current. The grounding electrode system typically consists of a ground rod, ground plate, or metal underground water pipe. The grounding electrode conductor connects the grounding electrode system to the neutral bus in the service panel. The size of the grounding electrode conductor is determined by NEC Table 250.66. When installing electrical equipment, it is crucial to follow all applicable codes and standards. The NEC serves as the primary guide for electrical installations in the United States, and it is updated every 3 years to reflect the latest advancements in electrical safety. Local codes and regulations may also apply, and it is important to consult with a qualified electrician to ensure that all installations are code compliant. Proper grounding is essential for electrical safety. It protects people from electrical shock, reduces the risk of fire, and ensures the proper operation of electrical equipment. Ignoring grounding requirements can have serious consequences, including injury, death, and property damage. Therefore, it is crucial to understand and follow all applicable codes and standards when installing electrical systems. The importance of using appropriately sized conductors for electrical installations cannot be overstated. Undersized conductors can overheat, leading to insulation damage, reduced efficiency, and potentially fire hazards. The NEC provides guidance on conductor sizing based on the ampacity of the circuit and the type of insulation used. Factors such as ambient temperature and the number of conductors in a raceway may also affect the allowable ampacity of a conductor. It is crucial to consult the NEC tables and follow the directing factors to ensure that conductors are properly sized. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. These devices interrupt the flow of current when it exceeds a predetermined level, preventing damage to the wiring and equipment. The NEC requires that overcurrent protection devices be properly sized to match the ampacity of the circuit. It is crucial to select the correct type and rating of overcurrent protection device for each application. Regular inspection and maintenance of electrical systems are essential for ensuring their continued safety and reliability. Inspections should be performed by qualified electricians to identify any potential hazards or code violations. Maintenance tasks may include tightening connections, replacing worn or damaged components, and testing grounding systems. A well-maintained electrical system is less likely to experience failures or cause safety hazards. When working with electrical systems, it is crucial to follow safe work practices. Always energize circuits before working on them, and use appropriate personal protective equipment, or PPE, such as insulated gloves and safety glasses. Never work on live electrical circuits unless absolutely necessary, and only then with proper training and precautions. Electricity can be dangerous, and it is important to treat it with respect. The use of ground fault circuit interrupters, or GFCIs, is an important safety measure in areas where there is a risk of electric shock. GFCIs monitor the current flowing in a circuit and quickly interrupt the power if a ground fault is detected. GFCIs are commonly required in bathrooms, kitchens, and outdoor areas. They can prevent serious injury or death from electric shock. Surge protection devices, or SPDs, protect electrical equipment from voltage surges caused by lightning strikes or other electrical disturbances. SPD divert excess voltage away from sensitive electronic equipment, preventing damage. SPD are commonly installed at the service entrance and at individual equipment locations. They can significantly extend the life of electronic equipment and prevent costly repairs. Electrical bonding is the process of connecting all metal parts of an electrical system together to create a low impedance path for fault current. Bonding helps to ensure that all metal parts are at the same potential, reducing the risk of electric shock. The NEC requires that all metal enclosures, raceways, and equipment be properly bonded. Proper bonding is essential for electrical safety. Electrical permits are required for many types of electrical work. Permits ensure that the work is inspected by qualified electrical inspectors to verify that it meets code requirements. Obtaining the necessary permits is important for ensuring the safety and legality of electrical installations. Failure to obtain permits can result in fines and other penalties. Electrical inspections are conducted by qualified electrical inspectors to verify that electrical installations meet code requirements. Inspectors check for proper wiring, grounding, overcurrent protection, and other safety features. Electrical inspections help to ensure that electrical systems are safe and code compliant. The importance of using listed or labeled electrical equipment cannot be overstated. Listed or labeled equipment has been tested by a recognized testing laboratory to verify that it meets safety standards. Using listed or labeled equipment helps to ensure that the electrical system is safe and reliable. The NEC requires that all electrical equipment be listed or labeled. When selecting electrical equipment, it is important to consider the environmental conditions in which it will be used. Equipment that is exposed to moisture, dust, or corrosive substances must be specifically designed for those conditions. Enclosures are used to protect electrical equipment from the environment. The NEC specifies different types of enclosures for different applications. Selecting the proper enclosure is important for ensuring the safety and reliability of the electrical system. The use of proper wiring methods is essential for electrical safety. The NEC specifies different wiring methods for different applications. Wiring methods include conduit, cable, and open wiring. Each wiring method has its own set of requirements for installation and support. The choice of wiring method depends on the application and the environmental conditions. Proper wiring methods help to ensure that the electrical system is safe and reliable. Electrical drawings or blueprints are used to plan and document electrical installations. Electrical drawings show the location of electrical equipment, wiring, and other components. Electrical drawings are essential for complex electrical installations. They help to ensure that the installation is done correctly and safely. When working on electrical systems, it is important to follow lockout/tagout procedures to prevent accidental energization. Lockout/tagout procedures involve disconnecting the power source and placing a lock and tag on the disconnect switch to prevent it from being turned on accidentally. Lockout/tagout procedures are essential for worker safety. The use of arc flash personal protective equipment, or PPE, is required when working on energized electrical equipment where there is a risk of arc flash. Arc flash is a dangerous electrical explosion that can cause serious burns and other injuries. Arc flash PPE includes flame-resistant clothing, gloves, and face shields. Arc flash PPE helps to protect workers from the hazards of arc flash. Ongoing training and education are essential for electricians and other electrical workers. Electrical codes and standards are constantly evolving, and it is important to stay up to date on the latest changes. Training and education help to ensure that electrical workers are competent and knowledgeable. The NEC is not a design manual. While it provides requirements for safe electrical installations, it does not provide detailed design guidance. Electrical design requires engineering expertise and knowledge of electrical theory. The NEC is intended to be used by qualified electrical professionals. The NEC is a living document that is constantly being updated to reflect the latest advancements in electrical safety. The NEC is updated every 3 years by the National Fire Protection Association, or NFPA. The NEC is a valuable resource for electrical professionals. The use of technology is changing the electrical industry. New technologies such as smart meters, energy management systems, and renewable energy sources are transforming the way we use electricity. Electrical professionals need to be familiar with these new technologies in order to stay competitive. Sustainability is becoming increasingly important in the electrical industry. Energy efficiency, renewable energy, and green building practices are all becoming more common. Electrical professionals need to be aware of these trends and be able to design and install sustainable electrical systems. The electrical industry is facing a shortage of skilled workers. There is a growing demand for qualified electricians and other electrical professionals. The shortage is due to a number of factors, including an aging workforce and a lack of training programs. The electrical industry needs to attract and train new workers in order to meet the growing demand. The future of the electrical industry is bright. There are many opportunities for skilled and knowledgeable electrical professionals. By staying up to date on the latest technologies and trends, electrical professionals can help to shape the future of the electrical industry.